Okay. Okay, next. So, first we have shown that the set, any set V, which contains the zero matrix. So, let's denote it by 0, which is the set containing 0 vector is a subspace because you can always get any scalar A multiplied by the vector 0, and it is also equal to 0. So any linear combinations derived by taking a linear combination of 0 is still in 0 tilde. So the 0 tilde or the set containing the 0 vector is a subspace. Next, any set of vectors that is of the form V equal to XA is a subspace. So if we will let that to be your V there, and this space here contains vectors of this form, any linear combination of, say, U, which is a linear combination of BV, you can show that it is still an element of V. U is still an element of B. So, because you can show it to be equal to X alpha for some alpha, which is a linear combination of a constant B and a vector A. So you can rewrite U as X alpha, which is an element of V. So any set of the form of vectors Vxa is a subspace. Next, we show that any set, say W, of this form, which is equal to 0, a vector which is equal to 0 of this form is also a subspace. So this W is a subspace. So let us see V here is n by 1. And X here is n by P. So prime here will be P by n. And V is n by 1. So the vectors in W will be a P by 1 vector. No? So these vectors will be P by 1 vectors. So how do you show that it is a subspace? First, you choose vectors in W. And AI are scalars because you are going to use that later when you do linear combination. So if the VI's are in W, then for any matrix n by P, you prime multiply it by its transpose, X prime VI will be equal to 0 for all I from 1 to P. No, because X prime V is a P by 1. Vectors in W are P by 1 vectors. So I from 1 to P. So once you identify the form of your vector, you define a new W vector, which is linear combinations of your V. Remember, V is in the W here for some scalars, AI. So R1 here is scalar. And what you do is you have to show that if we prime multiply W by X prime, this should be equal to 0. So that W is an element of W. So you started with a V, which is in W. You have a new linear combination W, so that pre-multiply by X is equal to 0 will show that W is in W and show that it is a subspace. So if we pre-multiply W by X prime, you will have this. W is of this form. Distributive property, you have this. And then since AI here are just constants in R1, you can take it out. But this form here will be equal to 0. So this is 0. And everything will be equal to 0. So we have shown that X prime W is 0 whenever W is a linear combination of V, which is in W. Hence, W will be in the set W because it satisfies this one. If we pre-multiply the vector W by X prime, it is equal to 0. So it means that W is a subspace. Subspace meaning closed under the operation of linear combinations. Questions so far? None. Silence means no questions. Okay? And the whole R to the n by 1 elements is also a subspace. No? So the proof is left as an exercise. So how do you prove this? You get elements of vectors in Rn, do a linear combination of U, and then show that W is also in Rn. Then that will be a subspace. Okay? Okay. Another definition that we have here is span and linear span. Okay? So assumptions, let Vi be in V, in the set V, where V is a subspace. So if it is a subspace, you can always make a linear combination of the vectors in V with some constants A. Now, the Vi span V if every element of V in V, no? So tanang vectors na nasa V can be written as a linear combination of V. So the Vi spans V if every V in V can be a linear combination of the Vi. So you can always, the vectors here can always be written as a linear combination of the Vi's in V. The linear span of V denoted by this symbol, no? So linear span siya is the set of all linear combinations of V. So daghan siya linear combination because every element man ang imuhang pwede himuan og linear combination. Every V in V. So ang set, the set of all linear combinations is called the linear span of V. Now if S is a subspace, then the linear span is also a subspace. So how do you show subspace gani? Closed. Under the operation of linear combination. So let's prove that the linear span of V is also a subspace. So again, to show that it is a subspace, To show that it is a subspace, magkuha mo vector na naa sa linear span. Uman, for some BI scalar, this is supposed to be BI, not I here, subscript BI. Okay? Mukuha mo element vector sa span, man for some constant, mag-define mo og linear combination aning vector na naa sa span. So, naa kay B1, this is B1, U1 to BR, UR, I from 1 to R. Ang imong gusto buhaton is kining vector na W dapat naapot siya sa span. No? So, note that ang atong mga U kay naman siya sa span. Kada isa sa ilaha, pwede nimo isulat as linear combination by definition of a span. Are you with me? By definition of a span, VI span V, if every VI can be written as a linear combination of the VI. So, kada isa sa ilaha, kini U1, kini dinhi, no? Kada isa sa ilaha, pwede nimo isulat as a linear combination for some constants Aij. So, si U1, masulat siya as in ani, A11, B11, dili ni siya A, in S ni siya. Okay, A11, B11. So, if you have your notes with you, i-edit ninyo. And then si U2, pwede po siya isulat as a linear combination until UR, linear combination. So this is S. Okay? So, nag-define ta og W, kini. Man atong gusto ipakita na naa siya sa linear span sa S. So si W kana siya. Pero kada UI equal to this. So pag substitute ninyo, man-distribute ang BI, mahimo siya ani. Are you following? And then you do that for all. Kini siya, gi-substitute for this. And then distribute, you will have this. Na? And then, kay scalar naman ng Aij, scalar po ning mga BR, pwede ta mag-define og Cij, which is the product of BI, Aij. So that we can write the value in this form. No? Kada component dinhi, mao na si C11, kana siya. And so on so forth. Now, scalar gyapon ng mga C11. So, ibig sabihin, si W is a linear combination of the original V with some scalars. No? So, that which is a linear combination of the vectors in S. So, W is in the span of S. So, that S here is a subspace. Okay? No questions? Chat. No need na, ma'am. Yes, ma'am. Para namin balikan. Okay. Makabalik ba ka ha? Okay. Let's have some examples so that you can picture out what is meant by span. So, let A be a subset in R3. So, three-dimensional lang, no? Three-dimensional. Say, vector X, Y, and Z. So X, Y, and Z, three-dimensional. So how do you describe the span of A geometrically? So specifically, suppose your set A, three-dimensional, A, 1, 2, 3, no? So the span is a linear combination. So multiplied by some constant C, where C is a constant. Actually, if you have Rn, it is just a line passing through the origin and 1, 2, 3. So the linear span na kay 1, 1, 2, 1, 1, 2, man 1, 2, 3, 1, 2, 3 na dinhi kay positive, negative maning sa Z dinhi. So 1, 1, 2, 1, 1, 2, 1, 2, 3. So dinhi dapit. 1, 1, 2, 1, 2, 3. Dinhi dapit. Okay, dinha dapit. So the span of 1, 2, 3, the point 1, 2, 3 is just the line passing through the origin and this point, no? 1, 2, 3. So kung kini si 1, 2, 3, this is your span of A. Specific 1, 2, 3. In other words, subspaces of dimensions 1 are lines through the origin. Say, for example, you have a set 1, 0, 0, 0, 1, 1. Then the span, this is supposed to be B. The span of B, you have that linear combination, A times the points 1, 0, 0 and 0, 1, 1. Where A and B here is a constant, is a plane. So kung in-ani na siya, plane na siya, space kanang ana na siya, no? A plane or papel, no? Na forma passing through the origin and these points. So kung naa kay 1, 0, 1, 0, 0, dinhi na siya. Then 0, 1, 0, dinhi. So naa kay origin dinhi. So you will have plane. Murag papel na moagi aning tulo ka points, no? Di na ako ma-drawing kay basta naa siya diha. Saon man na pag-drawing na na-contain. Anyway, if in other words, subspaces of dimension 2 are planes through the origin. Imagine ninyo na ang papel ni agi sa origin. Og ani kini na duha ka point. So, picture man siguro na ninyo. Kaya lang plane na siya ha. Papel na siya na niagi diha ng mga points. So that is span. It can be lines or it can be planes. So kung higher dimension, lisod na imagine. Okay? Okay, the only subspace of dimension 3 is R3. And the only subspace of dimension 0 is the origin. Okay, next. Let's define linear dependence. Linearly independent. So, the VIs are linearly independent if kini assumption no? Assumption. Wala mo, P implies Q. So, ibig sabihin, assume P, ipakita si Q. So, V, linearly independent if, kung mo assume ta kini na linear combination, no? Kini na linear combination. Pag equal to 0 na siya, mapakita nato na tanang A, mga constant diha is equal to 0, then we say that the VI are linearly independent. Otherwise, if there exists na isa na AI, there exists some AI na dili equal to 0, then we say that the VI are linearly dependent. No? So mao na ang opposite. Kay for all man tanan sila. So kung naa lang isa na dili equal to 0, it means that the VI there are linearly dependent. Okay. So suppose your set S, UVW be a set of polynomials of degree 2. Ibig sabihin, exponent 2. Here. Degree 2. Of degree 2. And then, with this equation, no? So, U here, kini siya is 40 squared minus 90 minus 5. V here is t squared minus 80 plus 2. And W here is 3t squared minus 5t minus 1. We want to show that S is linearly independent. So, kung gusto ta magpakita na linearly independent, naatay constants na i-define such that ang linear combination ani, if it is equal to 0, then the constants are all equal to 0. So, saan pagpakita na linearly independent? Naa kay maglet ka og A, B, and C, which are constants. And then, ang linear combination na AU plus BV plus CW is equal to 0. Kung maglet ka ani, imong i-show na si A, si B, ug si C is 0. Pag magpakita na nimo, then the set S is with these vectors U, V, and W are linearly independent. So how do you do that? Nako, na ba ko yung space din eh. Okay, let me have a space here. Can you see my writing? Can you see my writing?
Yes, ma'am.
Yes, ma'am.
So these are constant, no? Then AU plus BV plus CW equals 0. Sa atong gusto. If this is true, if this is equal to 0, we want to show that A, B, and C equal to 0. Okay. So, ang may tabuan may mo ni siyang A times, ang U? 40 square minus 490 minus 5 plus B, and you will have what? Ang V na to is T square minus 8T plus 2 plus sa atong C, W, 3T square minus 5T minus 1. And then, i-join mo tanang T square. So, unsa may nasa T square? 4A plus B plus 4A plus B plus 3C T square plus say nasa T. Sige daw? Isa mag-dictate.
-9, -8, kag -5 lang.
-9A Sunod.
Minus 8.
Minus
8.
8
8.
B. Sunod.
Minus 5C.
Minus 5C. Sa'yo nabilin. Plus. Saan ang third term?
Negative 5. Negative 5A.
Hmm.
Negative 5A plus
Plus
2B
2B minus C.
minus C.
Oh, equal to 0 na. No? So, pangitaon dahil na nato ang atong gusto isyo na A, B, and C are all equal to 0 for us to say that U, V, and W are linearly independent. So, ang may tabuan na, kuhaon ninyo, kana, ug kana. Ehe. Asa naman to? Ay, nako. Uy, nawala. Okay, so, kuhaon to na to katong term. Ang primero ato, katong ang first term ato is 4A plus B plus 3C, no? And then, di ba naman to? B square plus minus 9A. Okay pa ko sa inyong screen?
Yes, ma'am.
Yes, ma'am.
Minus 5A plus 2B minus C. Gusto ni nato equal to 0. Kano sama na equal to 0? Kung mapakita na ito na si 4A plus B plus 3C is 0. Si minus A minus 8B minus 5 is 0. Ug minus 5A plus 2B minus C is 0. No? Kano sana equal to 0 kung mapakita nato na 0 ni? Or equivalently, in vector notation, a matrix notation na aka in ani. Man times A, B, C is equal to 0, 0, 0. So, ang inyong buhaton is, pwede din Sa kay buhaton ana to solve for A, B, and C. Elimination and substitution. Are you with me?
Yes, ma'am.
5C ni. So you do elimination and substitution and try to obtain A, B, C. Sige daw. Trabaho daw. Kinsay maka share screen. Okay, akong Kinsay makasolve. Nay makasulat sa inyo ha, parehas ako Dumagin. Or care. Can you share your screen and show that algebra raman Para napon mo'y buhaton. Akong i-co-host. Kinsay makasuwat. Mag-elimination substitution lang. Oy.
Wait lang, magbalins ako sa laptop, ma'am. Wait lang.
I-co-host ta ka. Kisa to, si Kier? Mag-solve ka, Kier? Algebra raman to.
Ma'am, wait lang. Ako sa balin sa laptop ako pag-connect.
Co-host. Kier. I-stop sa ng recording. Share para dili taas.